Okay, welcome to the fourth video in our factorizing and expanding series. Now, this time we're going to work out how to factorize this. And previously we had done only factorizing binomials. So for example, 5x squared plus 10 with 2 terms, but this one has 3 terms. And technically this is called a monic quadratic. Monic means that, a quadratic is just an expression with x squared or something squared in it. And actually, it's not quite true. If I have x cubed, that's called a cubic. But a quadratic is when the highest index on the variable, like x, is a 2 or a squared. So anyway, this is called a quadratic. It's called a monic quadratic because there's no coefficient over here, which means basically that the coefficient is 1. And if you think of mono, if you have a monobrow, that's like one eyebrow. Mono means 1, and monic means 1. So the coefficient is 1. So I'm going to teach you how to factorize quadratics where the coefficient of the x squared is 1, or it's just x squared here. In other words, if you have a 2 here, it gets more complicated, and I'll show you that in a later video. Okay, now we're really using the fact here that expanding is the opposite of factorizing, and factorizing is the opposite of expanding. So we're going to get to this in a second, this particular example. But first I need to show you what happens. Okay, when you factorize this, you're going to get 2 brackets, and there's going to be 2 terms in each bracket. So what I'm going to do is we're going to go backwards. We're going to expand this, which is our final solution should look like this, and we're going to expand it, and then we know that factorizing is just going backwards to that. So if you expand it, this is what you get. You get x squared, x times x, plus bx, or the outside ones, plus ax, the inside ones, plus ab, which is the last ones. And you can actually take these two and just group those. It's kind of like factorizing, really. Bx plus ax. The common factor in here is x. And then you write the b here plus a. So we're doing that for a reason. And the reason is our final result is x squared plus something x plus something, or plus ab times together. Now, if I factorize this, I get back to here. Now, you might be thinking this is all a little bit different to x squared plus 5x plus 6. This doesn't, I don't see how this helps. So what I want you to do now, I mean, we're still wondering how to factorize this. But I want you to notice that actually this last thing that we've just expanded to is actually quite similar to our monic quadratic. Because I've got x squared here, that's the same. I've got a term, I've got something times x, and I've got just a constant term over here in both cases. The only difference is here I've got 5x, and here I've got this a plus b, and here I've got 6, here I've got a times b. So what this is telling us is if we can find a plus b that equals 5, And if that same a and b, you times them together and it equals 6, then I can write this factorized version up here. So to factorize this, and if you didn't understand any of that, that is okay. Ideally, we want to understand it, but if you didn't understand it, we just want you to understand this method of doing it. So you need to find two numbers, a and b, where a plus b equals 5, and a times b equals 6. So if a times b equals 6, that means a and b is a factor pair of 6. And then you can factorize. So what are some factor pairs of 6? I think that would be a good place to start off with. And we'll see if one of them adds up to 5. So we can do this factor pair list, which we did last time. 6 is 1 times 6, or 2 times 3. And I could write 3 times, and it'll be 2, but we've already got 2 and 3, so we don't need to do that. All right, so do either of these two factor pairs add up to 5? Can these two numbers be our a and b? Well, 1 plus 6 is 7, so that does not work. 2 plus 3 is 5. So a could be 2, maybe a equals 2, and b equals 3. Let's just double check. A plus b equals 5. Okay, 2 plus 3 equals 5. That's true. All right. A times b equals 6. 2 times 3 equals 6. All right, so a equals 2 and b equals 3. What that means is the answer to this, the factorized version, is we'll go back to here. If a is 2 and b is 3, we'll go back to this equation. The factorized version is x plus a, or x plus 2, times x plus 3. So that's equal to x plus 2, x plus 3. All right. Now, we've got 3 monic quadratic expressions here. So let's factorize them all. And this is telling us that we need to firstly find the factor pair of the constant that adds to give the coefficient of x. That's a lot of words. What does this actually mean? Find the factor pair of the constant. The constant is 12. So we need to find a factor pair of 12, and that factor pair has to add up to the coefficient of x, which is 7. So let's find factor pairs of 12 and see what we can find. So factor pairs of 12 are 1 times 12, 2 times 6, 3 times 4. Now let's test these out. 1 plus 12 is 13. Doesn't work. 2 plus 6 is 8. That's not 7. We want the factor pair to add up to 7. 3 plus 4 is 7. So that works. What that means is we rewrite this x squared plus 7x plus 12 equals, and this is the factorized version, x plus 3, x plus 4. Okay, so you might be thinking, you've just shown me a very complicated proof, and you're basically expecting me to believe that this is the factorized version of this. And yes, I am expecting you to believe it, but we can actually check this. Remember in the last video I said that if you expand it again, that's a good way of checking. So let's check it. Let's check it by expanding. So we've got x plus 3 times x plus 4. Now let's expand this. Let's multiply the first two. We've got x squared. The outer ones, that's 4 times x. The inner ones, that's 3 times x. And the outside ones, sorry, the last ones, which is 12. Now, you might be thinking right now, I knew it. It was too complicated, it didn't make sense, and it doesn't work. You know, this x squared plus 7x is plus 12 is different to this. But if you collect the like terms here, 4x and 3x, 4x plus 3x is 7x. So now hopefully you can see that we did in fact get back to where we started. And that means we've shown that these two things are equal to each other. If you factorize, you go from here to here, that's what you get. And if you expand, you get this one. Okay, let's do a couple more examples. And I might just go back to this previous slide and we'll do these two examples. So, now this one's a little bit tricky because you've got, instead of positive numbers everywhere, you've got a negative number here, -8. But we're just going to try and find factor pairs of 8, first of all. So 8 equals 1 times 8, not very useful, or 2 times 4, 3 doesn't work, and then 4, we're just back to this one. So here's our factor pairs. Now, we know that actually we're trying to get -8. So we've got a lot of options here now, and we can play around with them. If I'm multiplying two numbers and one of them's negative, sorry, let's say that again. If I'm multiplying two numbers to get to a negative number, one number has to be negative and one number has to be positive. Because if I have two positive numbers, that will give us a positive number, and if I have two negative numbers, that will give us a negative number. So that they won't work. We need one positive and one negative. So let's write -1 times 8 or 1 times -8. Same with this one, -2 times 4 or 2 times -4. Now if I add these two up, remember we're trying to add them up to get to -2. -1 plus 8 is 7. That's not right. 1 plus -8 is -7. Still not -2. -2 plus 4 is +2. You can do these in the calculator if you want to. 2 plus -4 is -2. So that's the one that we want. Okay, so that's equal to x. So a is 2, x plus 2, and b is -4. Two, that's our a and b. All right, let's try this last example. And so we're trying to find a factor pair of 6. So let's do our factor tree. Not factor tree, sorry, factor pairs. 6 is 1 times 6 or 2 times 3. Now, let's add these up and see if we can get -5. 1 plus 6 is 7, so that doesn't work. 2 plus 3 is 5, but that's not -5. So how do I get -5? And one way to think about this is, well, there's two ways of getting a +6 as an answer. Either both of these numbers are positive or both of them are negative. So let's try making them both negative. -1 plus -6 is -7. Still doesn't work. -2 plus -3 is -5. So that does work. So our two numbers are -2 and -3. Okay, that's how to factorize monic quadratic. Now we might as well just check this one. Let's just check this one. So if we're checking this particular expression to see if it works, we have to expand it. So let's expand it. X squared outer minus 3x inner minus 2x last. Negative 2 times negative 3 is positive 6. That's equal to x squared minus 5x plus 6. All right. Now, again, if you found that a little bit too fast or too complicated, I would suggest that you break it up into pieces and re-watch some of it. So in terms of re-watching, I would start from around here, the section of the video where I'm factorizing this expression here. That's where I would start from. And then, after you've watched that, see if you can do some questions.